Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 8-3. The statement is that the thin wall cylinder can be supported in one of the two ways as shown. So this is first way that is represented in figure A, and this is the second way that is represented in figure B. Determine the state of stress in the wall of cylinder for both cases. If piston P causes the internal pressure to be 65 psi, the wall has a thickness of 0.25 inch and inner diameter of cylinder is 8 inch. So let's start with the given data. So in given data it is given that this is thin wall cylinder, thin walled cylinder, okay, and internal pressure P is given as 65 psi. Clear? The thickness of wall is equal to 0.25 inch. Clear? And inner diameter, which is di, is equal to 8 inch. So from inner diameter we can get inner radius if we divide 8 by 2. So 8 by 2 is equal to 4 inch. So what we have to find is to find the state of stress in the wall of cylinder. So sigma 1 and sigma 2. Sigma 1 is hoop stress and sigma 2 is, I will write hoop stress, and sigma 2 is longitudinal stress. For both the cases. Clear? So let's start with the solution. So for case A, you can see case A. So here you can see that longitudinal stress for thick wall cylinder is equal to sigma 1, that is equal to P into R divided by T. Clear? So P is 65 psi, inner radius is 4 divided by T is 0.25, and that comes out to be 1.04 ksi. So 1.04 ksi. I don't know what's 04 ksi. Okay, and longitudinal stress in this case will be equal to 0 because this is supported at this position. Now for case B, same sigma 1 is equal to P into R divided by T, and P is equal to 65 psi. Inner radius is 4 divided by thickness is 0.25, that is again equal to 1.04 ksi. But you can say this is the end of this cylinder is supported at these two positions. Clear? And here longitudinal stress will be equal to P into R divided by 2T. So 65 into 4 divided by 2 into 0.25, and that will be equal to 520 psi. Or you can simply take that longitudinal stress is equal to half of hoop stress. So half of 1.04 ksi will be equal to 520 psi. So this was the answer of our question number 8-3. I hope you have enjoyed it. Thank you for watching.